Number 1. What do we got? Anybody? B to the 8th power? B to the 8th power. Number 2. What do we got? N to the 12th power. Do we agree with that? Yep. N to the 12th power. Number 3. What do you got? Do I like negative exponents though? No. So what do I like instead? 1 over m to the 3rd power. I like that better. Yeah. 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 Missing term in the geometric sequence. Okay, so we know it's geometric. So we take our last number, we divide it by our first number, and we take the root to however many jumps that was. And in this case, 1, 2, 3, 4, 5 jumps to get that far. Okay? So that would be the 5th root. Well, luckily for us, 4 over 128 simplifies to be 1/32. So it's the 5th root of 1/32. 5th root of 1 is 1. 5th root of 32 is 2. So my jump is 1/2. So 128 times 1/2 is 64. 64 times 1/2 is 32. 32 times 1/2 is 16. 16 times 1/2 is 8. 8 times 1/2 is 4. Works out. Okay. Change here was plus 4. Change here was plus 2. So that would give me a slope then of positive 2. Change in f of x divided by change in x. Let's check it on some other ones. Change here was plus 6. Change here was plus 3. Still gets me a positive 2 slope. Change here was plus 8. Change here was plus 4. Still gets me positive 2 for my slope. Change here was plus 18. Change here was plus 9. Still gives me positive 2 for my slope. Doesn't matter which 2 points you choose to go from and then to. Okay? When we are given 2 points, then we subtract the y's over subtracting the x's. Oops. Seven minus 31 is negative 24. Negative 12 minus negative 6 is negative 6. Negative 24 divided by negative 6 is positive 4. So what we're going to do today, I handed out to you a Ziploc bag full of cards. Okay? So at this time, what I'd like you to do is I would like you to open up that bag and spread out your cards, because you're going to need to see what is written on all of them. Okay? Now, what you're going to be doing today is you and your table mates, oops, I should have gone down, not just to the next page. You and your table mates are going to be filling in these three boxes, this box, and this box, with the cards that you have out in front of you right now. So for instance, on this particular one, it tells me that the given function is -1/4 plus 3. So I would try and find on my cards, I would try and find whether or not the function is continuous or if it's discrete, and the domain of it. So you might want to like take the cards and sort them into like the domain ones go in one spot, the functions, another representation, etc. But for me on this one, I would say that this domain is F, card F. The domain of the function is continuous, and the domain is all real numbers. So card F would be that one, and I would put that then up in here. I would say this one is card F. Okay. The type of function is card, nope, 2/3. Type of function. There it is. Type of function and the growth factor. This is a continuous linear function because it has a constant difference of -1/4 over intervals of 1, or a constant difference of -1 over intervals of 4. This one doesn't have a letter on it though, but we'll go blank card. Okay. And then we have to find another representation for it. That would be this one right here. This graph would be the other representation for it. Okay? That one too, yeah. Well, blank graph card. Does that one have an E on it? Well, that's examples. Yeah. The rest of them I know have a letter on them. Okay? The little letter is up in the corner of the cards. It tells you which card it is. Okay? Right? So you and your table now are doing the rest of them. There's 6 more for you to do based off of that. Okay? No, you will not. Yep, you will not use it again. Agree? For number 2. For number 3, I got these. Agree? For number 4, I got F and J, but I couldn't find one for the type of function. But I do know that the function is exponential, and I do know that the R value is probably in the neighborhood of 2. Because it goes from 1 to 2. So it's multiplying by 2. And then it goes to 4. And then it goes to 8. What? Yep. Well, what do you mean is it increasing? The R value is 2, so yeah, so it is an increasing exponential function. With me? Unlike the 2/3 one, where that one was decreasing. Okay. For number 5, I thought card I fit for both the domain and the type of function, if memory serves me right. And I got J for another representation. Yes? No? Maybe? For number 6, I got P for the domain and C for the representation. It's arithmetic, and the common difference is -10. For number 7, I got L and E. This one would be exponential, and its R value would be 0.95. I couldn't find a card with that. For this one, I got H and N. It is exponential with an R value of 2. Multiplying by 2 every time. Yes, ma'am. Arithmetics are straight lines. Exponentials have a curve to them. Geometric is exponential. Yep. Mm-hmm. Yep. And number 9, I got F and K. This one is linear. And I think it's -22. Over 60. No, 50, yeah. Yep. Okay. Let's go through the homework tonight. Oops, went too far. So, on your homework this evening, you got a bunch of exponential problems. Find some missing value type ones. They're all geometric this time. Last time I think they were all arithmetic. This time they're all geometric. Then in numbers 13, 14, 15, and 16, it's asking you to answer these 4 questions for each of those problems. Okay? So there's 4 questions that you have to answer for each of 13, 14, 15, and 16, 17, and 18. There's 2 18s, actually through number 19. Then in the goes, there's 2 more geometrics to figure out. Two more in 23 and 24, and then some more finding the slopes in through 30. Okay? Sounds like a plan.